Yeah, it's a scrolling across the bottom there.
Yeah.
We actually have 2 calls in the queue right now. We have Chris called back, and then we have Steven. Do you want to go to Steven next?
Yeah, let's grab Steven and see what he's got to say.
All right. Steven, you are Steven?
Hello. Hey, how's it going?
Hey, you're on with Brian and Thomas. You got a supernatural claim for us that you'd like to discuss?
Well, I saw the lines were open, and I asked if it was limited to supernatural or not, and your friendly neighborhood atheist said that I could call in with something extraordinary if I wanted to.
Okay.
So I have something that I would imagine you guys would consider to be somewhat extraordinary. It's not too far out of the ordinary for my own self, but have you guys ever heard of this concept of ancient history being fabricated in the Middle Ages?
I've heard lots of claims about history being fabricated. I'm not sure about all of it. Why don't you elaborate a little bit for us?
Like sometime within the last 1500 years or so, people got history wrong and artificially extended it into the past. Have you ever heard of anything like that?
The phantom time hypothesis kind of stuff?
Yeah, it's in that ballpark.
Okay.
I've heard similar claims. Why don't you lay it out for us?
Well, I was just calling in to ask if you guys thought that just the concept of that is even possible.
I think that we have scientific time measurement that we can be pretty concise on these dates and stuff. That I don't know which period you're talking about. There's people that will claim that certain parts of the Roman Empire or certain any length of time between the fall of Rome and the Renaissance that there's missing centuries there, but through sciences like dendrochronology and radiometric dating, stuff like that, I think we can be pretty concise about the time that passed between the fall of the Roman Empire and the Renaissance. I mean, I'm welcome to hear evidence of the alternative, but that's what I'm understanding.
If you're wanting a response, I can tack onto that. If there was more that you wanted to add or to argue in favor of it, then I'm happy to do that first. But
no, go for it. Tack on.
Okay. So I've actually been, this is a field I've been diving into a lot lately with my Nothing Fails Like Bible History series, where I've been buried in ancient Sumerian history, ancient Egyptian history, Canaanite history. And this doesn't have so much to deal with the Middle Ages per se, but just in terms of how can we know how old something is? What are reliable signs throughout history that something did happen? And there's various gradients of credibility, various pieces of evidence that are more credible than others. So for example, if let's say that you find a written account that was written 500 years after someone's life and it mentioned them once, and that's the only piece of evidence that you have for them, that's not nearly as reliable as actually having, multiple written accounts that were contemporary, that were written during their life, and you found a body and you're able to carbon date it and it dates to that time period. And, there's more credible pieces of evidence that can stack up to give you a bigger picture of history. Now, that's just for one person. Imagine then taking that and extrapolating it out to millions of people throughout history, all, either dying, having their bones buried. We can dig up these bones, we can take DNA samples, and we can look and we can see, okay, with their DNA, someone who died 100 years ago is going to be much more closely related to us than someone that died 1,000 years ago, than someone that died 10,000 years ago. And there's a very consistent rate of mutation. So we can take DNA samples and we can go back tens of thousands of years. And there's more and more reliable ways that they can do this now. They're not just limited to taking DNA. Sometimes there was a breakthrough recently where they found proteins and they were able to roll those proteins out and find the messenger RNA equivalent and find DNA samples and sequence people's DNA based off of protein that they found that was native to their body. And so we're able to sequence DNA, and we know the rate that it changes from one generation to the next. There's different rates from your mother's mitochondrial DNA versus the male part of your father's sperm of your the Y chromosome. Sorry, and so you can trace back your lineage both with your mother and your father, and you can get a really big picture genetically of how people have changed over time and the rate that they've changed over time. And you can see when different cultures were last related to each other, when they last had a shared common ancestor, and how long they were separated. Because as they separate, they start having different mutations in different parts of their cells, their sex cells. So you can get a picture there with DNA. You can also then go and you can do digs.
Real quick, can I interject?
Sure.
That is interesting. Is there a term for that type of dating? Do you know?
Like genetic dating?
Phylogenetic mapping?
Biogenetic mapping is what that falls
Phylogenetic.
under.
So if you just Google search for like genetic dating, DNA analysis.
All right.
Yeah. There's a lot of.
So what was the second thing you were going to get into there? Sorry to interrupt.
Yeah. So that basically that's one method of dating actual organic material. Once it gets super old, once it gets past a certain point, then it starts to break down and decay to the point where you can no longer date it accurately. But you can pretty reliably go back, well through ancient history, at least the historical time period of the last like 10,000 years or so. History goes back to about 8,000 years or so of like written history. Or actually, I don't think it's.
You don't actually have to have the DNA of these ancestors either. You can find that DNA in each of us. There's DNA of thousands of different haplogroups, or not thousands, dozens of haplogroups and thousands of ancestors that we have, and we can chart, and you can see, when your family diverged from your neighbor's family in back in Europe. We don't actually have to have the people who lived back in Europe's DNA to do that. We can map that.
Well, so for example, if just to tack on what you're saying with that is, if you find like an isolated tribe that hasn't been contacted and you take a DNA sample, you can fairly accurately predict how far back in the past they diverged from humanity.
And it can go beyond humans too. I mean, that's how we understand about our evolutionary lineage. Our lineage is through different primates, through Australopithecines, back through Ardipithecus and things like that. It branches all the way back, and we can find those markers in our own DNA and
interrelatedness.
Mm-hmm.
Yeah. So to then give you like a bigger picture. So that's one way. That's one way of getting an accurate date or fairly accurate. Now there's some margin of error. It might be off, because there's mutation rates can vary a little bit, but they don't vary insanely. If all of a sudden you start having this out of control mutation rate, you get this thing called cancer and you die. So there's constraints on how fast your DNA can mutate. And so but because there is a little bit of wiggle room, then like the further back you go, the margin of error gets a little bigger. You can say, okay, they lived anywhere from, 2,500 to 2,800 years ago. So that you start to have a little bit of a range. But you can start to tune it in a little bit there's overlapping dating methods. You can, for example, use radiocarbon dating or various forms of radiometric dating to date the soil that something was found in and figure out when it was laid down. You can figure out, date the bones using carbon dating and figure out, the time that they died. You can use dendrochronology, which is the study of tree rings. And you can look at a piece of wood that was used as a tool in that time period, and you can look at the ring patterns. And depending on the type of tree and where it was, there's certain types of trees that are more reliable than others. Some have a very consistent rate of growing new rings where it's just one a year. Others will occasionally skip a year if there's like a drought or something. But when you're studying tens of thousands of samples, and you're studying a ton of different species and the limitations, then you start to get a really good picture. you couple that with you can date things using ice cores, and you can see with ice cores, you can see the rate at which these cores are laid down in the Arctic. And it's a very consistent, steady rate. And it's not just, oh, hey, it's, you know, a tenth of an inch every single year, and it was this many inches. What you actually see is throughout the seasons, there's different chemical signatures that spike and drop. And so as you take these ice cores and you lay them down on a plate and you melt them really, really slowly. And you start to see these chemical signatures they'll rise and fall. And you see an exact perfect line for like when each year and each season occurred. And so you can then measure other things in there too. You can start getting an idea of how much carbon was in the atmosphere. You can start getting an idea of, was there a volcano during that time period that caused a spike in carbon? And you can compare that with tree rings. And you can compare that with, you know, the level of carbon in that ring that was laid down. And so you start to get this really big picture that's overlapping. And then you add to that historical written records that are all over the world taking place and people writing things down. You get things like, you know, pottery and artifacts and art and different artistic styles changing over time. And we're talking millions, tens of millions of artifacts that are being discovered. So if someone came along in the Middle Ages and all of a sudden was like, all right, I'm just going to rewrite history and we're all going to get together and agree to like rewrite history and wipe out a couple hundred years, they would have to dig up every single artifact and destroy them, you know, tens of millions of artifacts all across the world that we're still discovering to this day that have been untouched in the ground since they were first laid down. They would have to get rid of all of these skeletons. They would have to plant new skeletons and alter the DNA inside of them. They would have to mess with the ice cores and all of the pieces of wood that we find. It would just be entirely unfeasible. I don't know if that helps.
Well, it sounds like it would be quite extraordinary.
Yeah, it'd take a lot of effort to wipe out a time period like that.
It would be effort so gargantuan that it wouldn't even be remotely possible for us now, much less in the Middle Ages.
All right. Well, yeah, I think that was a decent response. Definitely touched on quite a few different scientific dating methods.
All right. Well, we appreciate your call there, Stephen. We're going to go ahead and pop back over to Chris here because we had his call drop earlier, and we're going to see what he has to say. But you have yourself a nice evening, okay?
Yeah, you do.
Real quick on this note, before we're about to take the next call, one of the things that I learned while I was studying ice core dating is these machines. I just want to give people an idea of just how accurate they are, how precise the measurements can be as they're melting these cores. And the machines that they're using, we're talking like $1 million machine that's like slowly melting the ice cores, and they're measuring like 18 different chemical signatures all at the same time in real time. And one of them, it was something like the number of atoms in like parts per billion or whatever that they were able to detect. The precision would be the equivalent of being able to fill up an entire Olympic-sized swimming pool with grains of sand and do that 18 times and tell you exactly which one of, you know, the 5 grains of sand that are in those swimming pools happen to be black or happen to be, you know, gray or whatever. It's that level of precision. It's like, oh yeah, there's 5 and it's in these 18 swimming pools and it's right here.
Yeah.
It's insane. Like
it's amazing.
So when they make statements about, hey, 500 years ago, and this is one of the things that actually helps us understand a little bit about climate change and how the climate has fluctuated over time, is they're able to actually measure the carbon in the atmosphere very, very precisely and go back 500 years, 1,000 years, 2,000 years, and look at these changes to the point where they were even able to tell, based off of the level of iron, which was like a byproduct of gold smelting or silver smelting, I think, in the Roman Empire. They were able to see when there was an economic recession and decline, and it marked perfectly based off of the tiny amounts of iron that increased and decreased in these core samples during that time period. And like that just blows my mind.
And the thing about all these dating methods, the ones we just went over, like every single one of those is more accurate the more the closer it gets to modern times, and that's not just saying the closer it gets to modern times within centuries, within thousands of years, even we get so close. I know with dendrochronology, when you get within about 10,000 years, the margin of error is only like 24 years or so. It's very small. So the closer we get to modern time, the more accurate they are. So most of these theories, these phantom time hypothesis theories, are after the fall of the Roman Empire. So we have the documentation, scientific methods of documenting these time periods, along with the historical methods. It's be ridiculously I don't even know if it'd be possible at all for something like that to be pulled over the eyes of all the researchers looking into that stuff.
So I'll give you one example though of an area where scientists aren't sure, where the date starts to fluctuate. And it's if we go back to about 600 BC, that time period, we have very precise dates for figures that lived. And because a lot of times you might have a character that, if you look at the Egyptian kings lists, it's not necessarily precise because there wasn't a, hey, this is this time before Christ, because there was no Christ. So it's like, okay, what do you pin it to? So they might say, okay, this was in the year of so-and-so. Okay, well, when did so-and-so live? Well, that was 500 years before so-and-so. Okay, well, we know when he lived, so we can get a pretty good idea tacking it backwards that way. And sometimes we can date the bones and get a rough idea with some margin of error for about a 50-year time frame. So we'll find like the body of Ramses the Great in a tomb. He's decorated like a pharaoh. It says this is, the tomb of Ramses the Great, and we'll do some, carbon dating on it. And we're like, okay, it was somewhere in this range, but there's some level of floatability of those times, because you might have in that king's list some bodies that we can't find that are missing. And some of those pharaohs there may have been some overlap, and there may have been two people ruling at once. There may have been people who are missing who aren't listed there at all, who were attempted to be wiped out from history in what's called damnatio memoriae. Like there's different areas where there's a little bit of a question mark that you have to tap on things, but we can go back at least to around 600 BCE and have pretty damn good certainty of like when actual events happened. When you start going back further, one of the biggest tasks right now that historians are attempting to solve is the exact date of the Santorini eruption in Thera. And it's the reason that they don't know exactly when that happened is because you see like a couple of spikes of volcanic eruptions in the ice cores. And you also have in dendrochronology, you have a couple spikes, and they're trying to figure out exactly which one was that eruption versus a different one. And when you carbon date samples that from that time period, because carbon dating 3,500 years ago has a little bit of wiggle room of about 100 years or so, then they're off by maybe 50 years one way or the other. And so it's, you go back 3,500 years and it's like, okay, we know within about 50 years, give or take each way, about when something happened, but we don't have the exact date. Well, we're getting there. And every single scientific breakthrough gets us a little bit closer and dials the precision a little bit more. And we start, having these breakthroughs with ice rings and all these breakthroughs with measuring, coral samples and measuring tree rings and stuff. And it gets better and better and better and better. So for someone to just say that time is missing, scientists and historians, they were off by this much. Well, our calibration tables have gotten bigger and bigger and more precise. Our tools have gotten better and better and more precise. So to say we're missing several hundred years in the Middle Ages, I think is a little bit more than a tad absurd.
Yeah, a little bit ludicrous.